Question number 2. The flowchart in figure 2 shows the process involved in the manufacture of sulfuric acid. So we have the process here, the figure 2. We have sulfur, we have air, chamber 1, we have chamber 2, we have oxygen added there, chamber 3 catalyst, then we have chamber 4 substance M, chamber 5, and we have a substance N is added, we have sulfuric acid produced. So part A, explain how the sulfur used in this process is obtained. So basically, this is what we call the flash process. Or you can say 3 consecutive, you say 3 concentric pipes forced ground. So that is the process. And you can describe this by saying, the first one, we have innermost pipe. The innermost pipe contains hot compressed air. Hot compressed air. And you get a half for that. Then we have outermost pipe. Outermost pipe. So outermost pipe contains superheated water. Superheated water. About 170 degrees centigrade in terms of temperature. Then we have the middle pipe. The middle pipe is where now the molten sulfur comes out. Molten sulfur out, get out. So that's how you describe the process. Alternatively, you can draw a diagram. Let me use this space here to a well-labeled diagram, which is still okay. So I'm going to. So that is the outermost. This is where we have the outermost pipe. We have another pipe here, which has an inlet. An inlet, so that is that will give us then we can drop it here so that we can have the innermost pipe with an inlet outlet there. So this contains superheated water. So from there we complete this and we have that. Then we have finally we have this, the outermost pipe, and it has an outlet. So this is the 3 pipes that we have described here. So we have the outermost pipe. We have said superheated water. Superheated water. This is about, we have said it is about about 170 degrees centigrade under pressure. And this is at, we can say 10 atmospheric pressure, 10 atm. So you label that. This other one, the other pipe, the innermost pipe, we have said it is compressed. It has hot compressed air. Hot air, hot compressed air, probably at 15 atmospheric pressure. Then we have the outermost. This is the outermost. Then we have the middle pipe. It has molten sulfur. Molten. This is sulfur. So then you can put here. So here we have, this is the ground. That is a ground. Then we have sulfur beds. We have sulfur. Can just write it here, sulfur. Sulfur beds. So if you draw, so this is ground level. So if you draw that diagram, then you should be able to get 2 marks, or you describe it here. Part B, give one advantage of using air in chamber 1 instead of using oxygen gas. So we can say air has oxygen, so it is a cheap source of oxygen. It's a cheap source of oxygen. You can also say it's readily available. We can just get air from the atmosphere. It's readily available. Or you can also say it is economical. Compared to oxygen. So compared to oxygen that is prepared in the lab. So that's how you answer that question, and you should be able to get 3 marks. As for part A, you can either draw the diagram or you can describe it the way I have described. That is a flash process. Describing what is contained in the 3 pipes. Part C, we are told identify substances. Roman number 1, M, you get 1 mark. Substance N, you get 1 mark. So we need to study the flow chart so that we are able to identify these substances, that is M and N. So we look at chamber 1. We have sulfur and air put in, and they are burnt. When they are burnt, we have sulfur 4 oxide formed and excess air. So we have sulfur 4 oxide plus air. In chamber 2, we have what we call purification and drying. So sulfur 4 oxide is dried, and therefore here we have sulfur. We have sulfur. In chamber 3, sulfur, when we this arrow here, we have going to chamber 3, we have dry sulfur. So when dry sulfur react with oxygen that is being put here, we have sulfur 4 oxide. So here we have sulfur 4 oxide, that is sulfide. So sulfur 4 oxide is formed. In chamber 4, a substance M is added, So substance M is added. It is conc sulfuric acid. Conc sulfuric acid. It is added. Then we have chamber 5. So once it dissolves in sulfuric acid, and what is formed is what we call olam. So this is H2, that is H2S2 O7. It is called olam. In chamber 5, a substance N is added. This is when you add water, HO2. So when you add water, now we have the olam it changes to sulfuric acid. So this is now sulfuric acid. So that is how the flow chart to work for you to be able to produce sulfuric acid. So what we have here is so our substance M is conc sulfuric acid, conc sulfuric acid, or we can say H2SO4. Then substance N here, we have said it is water. So we say it is water, whose formula is H2O. And you will be able to get 2 marks. Part D, we are told in chamber 2, drying and purification takes place. Give a reason why this is necessary. So this is chamber 2, where we have said drying and purification takes place. The reason is to remove the impurities, to remove the impurities which may poison the catalyst. To remove the impurities which may poison the catalyst. So the impurities may cover the catalyst and make it less effective or ineffective. So that's why we need to do the drying and purification. We go to the next part. Part D, we are told the reaction in chamber 3, this is chamber 3, is highly exothermic. That means it is producing, a lot of heat is produced. So part 1, we are told explain why high temperatures is required for the reaction in chamber 3. So to answer that, you say the high temperature increases or speed up temperature increases the rate of reactions. The rate of reaction, since particles have high kinetic energy. Particles have high kinetic energy. Hence more corrosion. Part 2, state how the heat produced in chamber 3 can be utilized. So that can be utilized by recycling to heat incoming gases. So we can say can be recycled to heat incoming gases. Incoming gases, that is incoming gases, i.e. Sulfur oxide and oxygen. So that is how you answer that. Let's go to the next part. Part E, we are told give a reason why this method of manufacture is known as contact process. So the reason why it is called contact process is because there is formation of sulfur oxide. Chamber 3 occurs when sulfur oxide and oxygen react, come into contact with each other on the surface of catalyst. So you say due to formation of sulfide, that is in chamber 3. In chamber 3 occurs when sulfur oxide and oxygen, sulfur oxide react, come into contact with each other. On the surface of catalyst. That is on the surface of the catalyst. So that is why it is called contact process. So let's go to the next part. Part F, we are told emission of gases in the sulfuric acid plant may lead to environmental solution. Part Roman number 1, state the evidence that could be used to show that the sulfuric acid plant causes pollution. So these gases, the sulfuric acid gases, when they get into contact with the water vapor, they form acid. This acid will cause damage to the environment. For example, metal structure near the plant erodes. Corrode, or they wear out. The other evidence that can be there is that stone or concrete stone structure wear out. Due to the acid. The other one is that vegetation near the plant die. Vegetation near the plant die or withers, dies or withers. That's another evidence. Another one is the people living around may have respiratory problems. So we can say respiratory, that is respiratory problems among those who reside near the plant. So those are some of the, so if you state one, you'll be able to get a mark, that 1 mark. The other Roman number 2, explain how the pollution identified in 2F Roman 1 can be controlled. This can be controlled by passing waste gases through alkaline. So you can control this by passing the waste gases through an alkaline. Or you can say basic, or you can say calcium hydroxide, basic or calcium hydroxide solution. So this will neutralize the acidic effect. Another one is by scrubbing the waste gases, by scrubbing the waste gases, mainly sulfur 4 oxide. So sulfur oxide, so that they don't form the acidic effect that will be able to harm, or that will be able to pollute the environment. So that's how you answer that.